Hello everybody, this is the Algebra 1A final study guide that I will be guiding you through today. Everyone should have a copy of this, and if not, it's on the blog. One post below wherever the heck I end up posting this. Let's go ahead and go through this. This is going to be a bit of a long one. I may have to pause it. We'll see what happens. But let's get going. We go back in the Wayback Machine to Module 1, Sequences. I'm going to go through each of these building blocks one by one and just kind of show you how I would recommend solving these problems. The way you do it may change, but as long as they're getting solved, that's what's important. First, equations and function notation. Remember, function notation is just the idea that f of x equals something. And this does not mean f times x, that just means there is a function. You know, the function notation means this is the function machine. Where, remember the function machine? It's usually a meat grinder, right? And we put something in, which is our x, and we get something out, which is whatever it ends up equaling, whatever our y value is. All right, so this is asking, given that f of n equals 8n minus 3, what is f of 1? And so all that's asking us to do is to take our f of n and plug 1 into our machine. So we're going to take 1 and we're going to plug it into our machine. And what is our function? Our function is it takes 8 times n and it subtracts 3. Right? So that means instead of an n here, we're going to put a 1. So f of 1 is going to equal 8 times 1, because that's what we have instead of n. 1 instead of n, thus we're going to put 1 instead of n, minus 3. Please excuse my dear Aunt Sally, we do multiplication first, so 8 times 1 is 8. And now we can subtract old Sally here, so we end up with 5. So our answer of f of 1 is 5. Easy enough. All right, the next problem is asking about exponents. And so if we have the same number multiplied by itself 4 times, so we have 1, 2, 3, 4, that's going to be the same as 15 to the 4th power. That's what it's asking. It wants to use it as an exponent, not multiply it out. I know you can multiply 15 over and over again in your calculators, but we want to be able to represent it with an exponent. So this becomes 15 to the 4th power. And so I'm going to do a little bit of extended knowledge on this. So 15 to the 1st power would just be 15. And then 15 times 15 would be 15 squared. And so when we look at this, when we look at 15 times 15 times 15 times 15, we can kind of view it as two things. We can see this 15 times 15 is 15 squared, and that this 15 times 15 is 15 squared, and they're being multiplied together. And so now you might be looking, well, how do we do 15 squared times 15 squared? Do I just square it on top of that? And the answer is kind of yes. We end up with 15 squared squared. And what does that mean? Well, whenever we have a power raised to another power, we multiply those. So 2 times 2 is 4. So we get 15 to the 4th power. It's kind of neat. Another way we can kind of look at this, and again, this is just extended knowledge. You don't need this for the test, but this is just the deeper stuff if you're interested. We got 15 times 15 times 15 times 15. Well, these 3 right here is 15 cubed, and then this 15 will just come on down. 15 cubed times 15, well, this is really 15 to the 1st. And so whenever we're multiplying a like base with different exponents, we just add our exponents. So that becomes to the 4th power. Kind of neat stuff if you're into those higher things of math. You'll need that in Algebra 2. Won't really need it so much with us, maybe a little bit at the end of the year. All right, so now we're going to build explicit and recursive equations. We're going to use the given information to decide which equation will be easiest to use to find the indicated value, find the value, and explain your choice. So we're given an explicit equation, we're given a recursive equation, we're given the first, second term, and we're wanted to find the 5th one. So which one is going to be easier? The explicit, because the previous term would mean I'd have to add 3 every time. So I'd have to go, you know, if term 1 is 10 and term 2 is 13, I'd have to go term 3 is, well, I see that I have a common difference of 3, so that's 16, team 4 is 19, team 5 is 22. I'd have to do this over and over again until I get to 50. I'm already tired of doing it, and I'm at 5. Okay, so I want to use the explicit equation. It's a little bit more powerful, and so I know that my term is 50. So y equals 3x plus 7. Well, my term is 50, so that's what I plug in for x. So y equals 3 times 50 plus 7. Please excuse my dear Aunt Sally, I got to do multiplication first. So y equals 150 plus 7, which of course is 157. That is my answer, 157. An explanation, how did I do this? I used the explicit equation because adding recursively was going to take a long time. Boop, boop, boop. All right, cool. Graphing. Let's move this up. Scooch, scooch. All right. Graph the ordered pairs from the table on the graph. So if x is 1, y is 4. Here is 1, 1, 2, 3, 4. Boop. 2 is 7. 2, 5, 6, 7. Boop. 3 is 10. 3, 8, 9, 10. Boop. 4 is 13. 11, 12, 13. Boop. And I'm done. That's it. I've graphed my points. Remember, like this line here is always x, this line here is always y. Scale worked out. Good to go. All right. Shoom. Let's go to 1.5 through 7. Wants us to find the missing terms of this arithmetic sequence. And of course, arithmetic means we add. In this case, we're going to be adding a negative number, so it's the same thing as subtraction. So I go from 7 to 4 to negative 1. I can tell that I'm subtracting 4 at each step. Negative 1 minus 4 is going to be a negative 5, which is going to be a negative 9, which will lead us to a negative 13. My common difference is negative 4. If I did not see that my common difference was negative 4 and it's arithmetic, I can take any term and subtract the term before it. Okay, so I could take, in this case, like I could take the second term, and subtract the first term. The second term was 3, the first term was 7. That will give me negative 4. That's my common difference, okay? And so from that, you can figure it out. 2 consecutive terms in a geometric, so when it's geometric, that means we are multiplying. And sometimes we multiply by a fraction, which looks like division. 2 consecutive terms of a geometric sequence are given. Find the recursive function. So I go from 20 to 10. I can see that that is half. If I did not see that that was half, one of the ways I can extrapolate that is I could take any term and then divide it by the previous term, x minus 1. So for example, I could take the second term, or in this case the third term, because that's what it gives me, divide it by the second term. So I could take 10 divided by 20, and that would give me 1/2. This would be my common ratio. Okay. But I could also just see that 10 is half of 20, so the next step, my f of 4, my fourth term, is going to be half of 10, which is 5. And my fifth is going to be half of 5, which is 2.5. Okay. And so what's my recursive function? My recursive function is f of x equals f of x minus 1, and then I'm dividing by 2 or multiplying by a half. I prefer to write it as multiplying by a half because that's my ratio. Remember, the general form of geometrics, recursive formulas, is going to be f of x equals f of x minus 1 times our common ratio. Right? We were able to figure out this was our common ratio. That's why it's there. Next, the same sequence is shown in both the table and a graph. So these are the same thing. Indicate on the table where you see the rate of change of the sequence, then draw on the graph where you see the rate of change. So I have to show how I see the rate of change. And I see the rate of change as I go 1, 0, 2, 4, 3, 8. I see that the rate of change is 4, and I see it because we're adding 4 at each step here. So to show that, I would do this. That's 4, and then this is 1, 1, 1, 1. And so n is essentially my x, f of n is my y, and remember, rate of change rate of change, is delta y over delta x. So in this case, I'm changing 4 and 1, so it's just 4. Now here, same thing. I see that I go up 4 on my y over 1 on my x. Up 4 over 1. Up 4 over 1. Up 4, whoops, over 1. Got a little sloppy with my line there. But you can see that my change in my y value, because this is y and this is x, my change in my y value is 4, and my change in my x value is 1. So 4 over 1, or simply 4, which is what we got here, which is good because of the same thing. That's it, rate of change. We call these slope triangles. You may have forgotten that. That's how we calculate slope, is that rise over run, which is otherwise change in y over change in x. So whenever we do that, we call those little things slope triangles to figure it out. Moving on. So now we're going to do 1.8 through 11. So the very first building block is to find the missing terms of arithmetic and geometric sequences. I believe this one's an arithmetic. Yep. So we want to find the common difference. So this time we're not given consecutive terms. It's really easy when we're given consecutive terms. But unfortunately, we're not. So we have to kind of figure out what's going on here. And so one of the ways we can do this is we can kind of build an equation. Because I know that 16 plus whatever my common difference is will get me this second term. Then if I add that difference again, that would give me my third term. And then if I add that difference again, that would give me my fourth term, which I know is 4. So if I take 16 and add some number 3 times, it's going to be 4. Well, that's 16 plus 3d equals 4. And now I just solve for d like I would any other two-step equation. I would subtract 16, 3d equals a negative 12. I would divide by 3, such that d equals a negative 4. My common difference is negative 4. Now another way we can do this is we can view these as points. We could view this as point 1 and point 2. Right? Because we could view this as though it was on a Cartesian plane. We could view it as though, you know, we had 1, and then like 16, and then 4, and 4, right? And we could view this like such and try to find the slope of the line. Because we know from the slope formula that y2 minus y1 all over x2 minus x1 is my slope, where y2 is my 0.2 y value, which is 4. I'll subtract y1, which is my 0.1 y value, which is 16. Then my x2, so the x value of my second point, is 4. And I subtract my x1, which is the x value of my first point, which is 1. So this gives me a negative 12 over 3, which ends up equaling negative 4. Same answer. So either of those methods will work depending on what you're more comfortable with. This one requires a little bit more creation, where you're kind of creating a pattern and seeing how it works. Slope formula is a little bit more powerful, but you do have to recognize that these are in fact coordinate points. We would then fill in the blank. 16 minus 4 is 12. 8, 4, 0. Boom. All right. Let's scooch this up for the next problem. Building block, recursive and explicit equations. So we have a sequence here. It goes from 60 to 30 to 0 to negative 30. So is it arithmetic? Am I adding a number? Geometric? Am I multiplying, or is it doing something different? Well, from 60 to 30 is either subtracting 30 or dividing by 2. Okay. From 30 to 0 is subtracting 30 or dividing by, well, there's no way to divide a number so that it gets to 0. It just actually cannot happen mathematically. And then it goes to negative 30, which is another subtracting of 30. So I'm doing an arithmetic sequence. I'm subtracting by 30 each time. And so it asks me the recursive equation. And so I have to remember that the general form of recursive equation for arithmetic recursive is f of x equals f of x minus 1 plus the common difference. Okay? And so for this recursive equation, I would know f of x equals f of x minus 1 plus the common difference, which is negative 30, so I'd just say minus 30. Cool. And then I have to do the explicit equation. And I have to remember that the arithmetic explicit is f of x equals my n sub 0 plus my common difference times x. So in this case, I have to find my n sub 0. So f of x equals, well, this is my first term. That's n sub 1. So I got to go backwards. And if I were to go backwards, I would know I'd be at 90. So it'd be 90 plus, but actually it's minus because it's negative 30 is my difference, x. So that's my explicit. It's kind of neat. It's kind of neat stuff. Alrighty, let's go ahead and move on up. Building block, the equations of a line. So I want us to write the equation of the line in y equals mx plus b form. Name the values of m and b. Recall that m is the slope and b is the y-intercept. Okay, so m is the slope. So we did those slope triangles earlier. To figure out the slope triangle, we got to find where it crosses perfectly on our Cartesian plane. So it crosses perfectly here, and it crosses perfectly here. And so to find slope, I got to do a little slope triangle. I see that I go up 3, and I go over 1. And so slope is rise over run, which is my change in y over my change in x. So I rose 3. I went from negative 1 to 2, so my change was 3. And my x is 1. I ran 1. I went from negative 1 to 0. That's 1. So I know that my slope is 3. B is just the y-intercept. So this is my y-axis. I just have to see where it crosses the y-intercept. And it crosses right here at 2. 2. So if y equals mx plus b, y equals 3x plus 2. Pretty cool. I want you guys to see the connection here between this and the explicit equation of an arithmetic sequence, because it's pretty much the same thing. If y equals 3x plus 2, well, plus 2, this is the same as my n sub 0, right? When my terms are 0, what is my y value? 2. And then 3 is a slope. This is the same thing as my common difference. Every time I take a step, I'm going up 3. It's the exact same thing. So I want you to be able to see that relationship. Uh-oh. Looks like I got a little bit of a frozen screen here, which is always fun. So I'm going to go ahead and stop the recording. Hope you guys see this stuff, and I'll come back with Module 2.